guys, so hopefully you finished up the lab and started to understand a little bit about valence electrons and group trends with that. And the main thing is that groups or elements in the same group have similar properties because they have the same number of valence electrons. So we're going to start talking about valence electrons and energy levels, and we're going to start talking about how to draw these things right here, the Bohr models. We talked about Bohr models before, so we're going to learn how to draw those today. So first, let's label this one with what a valence electron is and what an energy level is. And so you guys can do this now, or later on we're going to draw some that you can label. So if you don't want to have to draw this whole thing out, you can do this later. But right here, this is a valence electron. And we have talked about this before, how the valence electron is what's in the outermost shell. So that's what that is. And then our second thing we're going to label is an energy level. So these rings, each one of the rings is an energy level. So here is one energy level. This is our outermost energy level. Okay, so we have valence electrons and we have energy levels. Now let's start talking about how we're going to be able to draw Bohr models. So there's a few steps that we're going to need to follow. So step one for drawing Bohr models. Okay, step one. Our first step is we're going to put the element in the middle. So you'll notice that above here, we put K right in the middle. So K is an element on our periodic table. It's in group 1 if you want to find it. Notice that we didn't put all the protons and neutrons there. We just put K so that you know that it has 19 protons and about 20 neutrons based on your periodic table. So you don't need to draw all protons and neutrons. You can just put the letter K and that's good enough for these. Then our second step is that we need to add electrons. So remember, our electrons are found outside in the energy levels, the different energy levels. And you'll notice that this inward one, this most inward one, actually only has 2 electrons in it. And then outward, this outward one has 8 electrons. And then this one has 8 electrons. And then this one only has 1 electron. And so there are some rules we have to know to draw these things. So electron energy levels can become full when they reach a certain number of electrons. So for that first energy level, or that first shell, it's going to become full after only 2 electrons are in it. So first energy level is going to be full at 2. So that's really important to know. Our first one is going to be full at 2. Okay, so we can't add 3, we can't add 4 in there. It's going to be full when we hit 2. Now, all of our other energy levels, our second one to our seventh one is going to have 8, going to be full at 8. So, second to 7th energy level, full at 8. I'll put electrons there to help you guys out. Electrons. Okay, so our second to our 7th is full at 8. Sorry, my handwriting is really bad. I haven't even been paying attention to it. Hopefully you guys can read everything. So those are our rules that we're going to follow. So we're going to work through some problems on how to do them. I'm going to do them. You're welcome to pause the video and try to figure out if you know how to do them. You're also welcome to watch me do 1 or 2 of them and then skip to the end to finish watching the last of my explanations if you don't want as much practice or don't need as much practice. But let's start off with a basic one. So the first one we're going to do is for lithium. So for lithium, we're going to start with our first step. It says element in the middle. So lithium on our periodic table, if you find it in group 1A, it's in period 2. So that's Li. And then we're going to put our energy levels. So for our first energy level, actually before we do that, let's see. How many electrons does Li have? If you look on your periodic table, you'll see it has electrons are 3. So for our first energy level, remember it only has 2 electrons in it. So we'll put 1 electron, 1 electron. And then for our second energy level, we need to just put 1 more electron, right? We're not going to make this one full. because there's only 3 electrons total. So that's how we're going to draw that. So we switched from our first energy level to our second one because we had 3 electrons, so only 2 could go in the first one, and then the last one had to go in our second energy level. All right, so that's how we do lithium. So let's move on to do neon. Okay, that's going to be our next one. So neon. So if you want, you can pause the video and try to see if you can figure out how to draw this yourself. But if you go and you find neon on your periodic table, it's in group 8A, period 2. So you find neon, you write it in the middle, and then I would put how many electrons there are. So on neon, there's going to be 10 electrons. So in our first energy level, remember there's 2, and now it's full. Now we need to do our second one. So our second one, it can do a total of 8 till it's full. And since we have 10 electrons, we already took away 2 of them, so now we have 8 that we need to put in there. So we can put all 8 into this energy level. All right, there we go. So you can count up your number of electrons if you need to. You can count and see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, we needed 10 for neon. We got it. We notice that now our energy levels are full. We have 2 in the middle and 8 on the outside, 1. So they matched up actually perfectly with it being full. So that's nice. So that's one example. Let's do one more example. Let's see. Let's do Na. So let's do sodium. So sodium is Na on your periodic table. You can find that in group 1A, period 3. So sodium is going to have 11 electrons. So electrons are going to be 11. So let's draw our first orbital around sodium. So we're going to have 1, 2. That's 2 electrons. Let's do a second orbital. We can do all 8 since 2 plus 8 is 10. Alright, so right now we have 10 electrons. We can count them up to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons, but sodium has 11. So we actually have to add a whole nother orbital around this, or a whole nother energy level, because sodium has to have 11 electrons. It can't have 10 electrons right now. So that's sodium. So let's try to look for some trends and some patterns here that we can see. So our first thing is, let's see how many valence electrons are in each of these. So lithium, valence electrons. Remember, it's our outermost electron. So there's our valence electron. So for number of valence electrons for the first one is just 1. And then let's talk about how many energy levels. So energy levels for our first one is, there's 1 energy level here, 1 energy level here. If you want to label it, if you didn't label the top picture, you can label these as energy levels. So we can see that we have 2 energy levels for lithium, 2 energy levels. So let's do valence electrons for this one. We can see that it actually has 8, 1, 2, 3, 4, 5, 6, 7, 8, 8 on the outside. So 8 valence electrons, and the energy level are 2. So this one for sodium, valence electrons are going to be 1, and our energy level is going to be 3, right? We have 1 here. Here, let me highlight it for you. We have 1 here, 1 here, and 1 here. So it's 3 total, 3 energy levels. So let's look at what group and what period all of these are in. So lithium is in, so its group is 1A, and its period is 2. It's in the second period. So it's in the first column and the second row. You'll notice that this starts matching up. You can start seeing that our valence electrons are going to equal what group it's in. We kind of learned that in our lab. And then you can start seeing that our energy level is going to match up with what period it's in. Okay, let's see for these next ones. So for neon, you can find neon in group 8A. Again, it matches up with our number of valence electrons. And neon is in period 2. The same as lithium. Lithium and neon both have 2 energy levels, so they're both found in the same period. Now sodium, it is in group 1A, which makes sense. It has one valence electron, and it is in period 3 because it has 3 energy levels. So you'll notice here that if we look at these examples, lithium and neon are both in the same period because they have the same number of valence electrons, or same number of energy levels, not valence electrons, same number of energy levels. Lithium and sodium have the same number of valence electrons, so they're in the same group. So we can start noticing some trends here. So our first trend is for the period number. So what does the period number relate to? Think in your head about these examples before. If they're in the same period, what do they have in common? All right, the same period is the same energy level. All right, so same period, same energy level. Now, if they're in the same group, what trend do you notice? So hopefully you can see that if they're in the same group, like lithium and sodium, they have the same number of valence electrons. Oops. So these are 2 super important things. I would probably highlight them in my notes because this is going to be really important. It's going to be able to tell you a lot about an element. You're going to be able to look at the periodic table now and say, if I said, how many energy levels does, let's say, nitrogen have? That's N. You can see that nitrogen is going to have 2 energy levels because it's in the second period. I could ask you, how many valence electrons does nitrogen have? And you could look and say nitrogen's in our 5A group, so it's going to have 5 valence electrons. So this can tell you a lot, and it's going to save you lots of time on your test and on your homework if you just memorize these rules right here. You could even write them on your periodic table, because like I said, you can use your periodic table on your tests. So write this little note on your periodic table for you to be able to remember. So now you guys are free to go work on your homework and finish your worksheet. Please email me if you have any questions. Hopefully this video was helpful and that you guys are starting to understand more about the periodic table.